Now, how the thermal circulation work? Suppose that a vertical distribution of pressure, exactly the picture A, the isobaric surface all lies parallel to the earth surface because there is no horizontal variation in pressure or there is no horizontal variation of temperature, and there is no pressure gradient, so there is no wind. So if you look at picture B, the atmosphere is cooled to north and warm to the south. In the cold, dense air above the surface, the isobar bounce closer together. On the other hand, in the warm, less dense air, they spread further apart. This dipping of the isobar produces a horizontal pressure gradient force and in the aloft, and that cause the air to move from high pressure warm air towards the lower pressure cold air. At the surface, the air pressure changes as the air aloft begin to move. As the air high above moves from south to north, air leaves the southern area and piles up above the northern area. This redistribution of air reduces the surface air pressure of the south and raises the surface air pressure to the north. So this results a pressure gradient force and at the earth's surface from north to south, and the surface wind begin to blow from north to south. We now have a distribution of pressure and temperature and a circulation of air. If you are looking at picture C, as the cool surface air flow southward, it warm and become less dense. In the region of surface low pressure, the warm air slowly rises, expands, cools, and flows out the top of an elevation about 1 kilometer above the surface. At this level, the air flow horizontally northward towards the lower pressure. So it completes the circulation by slowly sinking and flowing out the bottom of the surface high. Circulation, these types of circulation brought on by change in air temperature. In this situation, warmer air rises and colder air sinks. So it's called the thermal circulation. So thermal circulation also led by thermal high and low. Next we'll be talking that in the next slide. So the thermal high and lows, the region of surface high and low atmospheric pressure created at the atmospheric either cool or warm, they are called thermal cold core high or thermal warm core low. In general, they are shallow system. Usually those system extends no more than a few kilometers above the ground. This system weakened or weaks with the height. For example, we can say that the surface atmospheric pressure is lowest in the center of the warm thermal low. In the warm air above the low, the isobar is spread apart, and at the some intermediate level the thermal low disappear and actually change into high. A similar pattern we realize happens above the cold thermal high. The surface pressure is greatest in its center, but because of the isobar aloft are crowded together or closely spaced due to the cold, dense air, the surface thermal high become a low in above a 1 kilometer or a kilometer above the ground. So we can summarize the typical characteristics of thermal pressure system as shallow, weakening with the height, and it is being maintained for the most part by local surface heating and cooling.